So for section 11.7, I'm just going to walk through. These are my completed notes, which are posted for you in D2L. And so I'm just going to walk through. There's just a few things I want to point out to you. I'm mainly going to focus on the new thing here, which is dealing with permutations. And I just want to kind of point out a couple of things as far as when to use them and how to evaluate them. So the first part of your notes for section 11.7 is really just a review of the fundamental counting principle. And we talked about this in my video for section 11.4. And it basically just says, if you have multiple things that are occurring together, you can break them down into individual pieces, count the number of outcomes for each piece, and then multiply to get the total. Now, one thing I will tell you here, I did a little bit of this in 11.4, but anytime I'm using the fundamental counting principle, if it's not really easy for me to see what needs to be multiplied, then what I like to do is kind of lay things out almost in terms of blanks, like how many things do I need to assign, because then it makes it easier for me to look at each piece individually. So like, for example, here, when I see that, okay, this is going to be 2 lowercase letters and 4 digits, right? It's not a situation where it's telling me, there's 3 appetizers, there's 5 meals, there's 6 desserts, right? Where it's easy to know what numbers need to be multiplied. So what I do is I lay out blanks for each thing that I have to assign. And notice I did that here. So like for part A, these blanks represent the 2 lowercase letters, and then these blanks represent the 4 digits. All right, so then I just go to each one and I write down the number of possibilities. All right, for letters, there are 26. For digits, there's always 10. All right, remember, always 10 possible digits, because a digit can be anything from 0 up to 9 in terms of whole numbers. And this also makes it easier if I have to account for things like I can't repeat, right? Well, in that case, I just say 26 for the first letter, but it has to decrease by 1 for the second, all right? 10 for the first number, and then decreasing by 1 all the way through, all right? It also makes it easy if specific numbers have restrictions. So like the first letter must be a vowel, right? That means there's only 5 options, A, E, I, O, U, right? The second letter can be anything except for the first one, because there's no repetition here. And then the first digit cannot be a 0, so that leaves 9 possibilities. The other digits can be anything except for the one that came before. And that's why we're looking at 9, 8, 7. So anytime you're having trouble, a similar situation here in the second example, anytime you're having trouble figuring out what numbers need to be multiplied, make yourself little blanks like what we're doing here. And then you know exactly what you're looking at for each blank. You determine the number of possibilities, and then to finish, you just multiply. All right. Now, the new thing in section 11.7 is what we call a permutation. All right. This is particularly when we're looking at a situation where we want to arrange objects in order. All right. Anytime you're talking about arranging objects in order, all right, we have a rule defined here that says the number of possible permutations, right? We're counting. The number of ways that you can arrange objects in order can always be found by taking in the number of objects factorial. All right, now if you're not familiar with a factorial, factorial is always just a product where you take that number, multiply by the number below it, until you get down to 1. For example, if we were doing 8 factorial, you start with that number, and then you multiply by every integer until you get down to 1. All right? Down here I did 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. So the first example here this is kind of laid out for you, right? If we have 3 objects, right, these are all the different ways that we can arrange the objects in order, right? Which object comes first, second, third, all right? And there's 6 possibilities. So what our factorial rule here says is, okay, if you want to know how many possible orders there are, take the number of objects, which is 3, and evaluate its factorial. That would be 3 times 2 times 1, which is 6. Okay, so again, this rule is kind of like a shortcut. Anytime you want to know the number of ways you can arrange objects in order, take the number of objects and evaluate its factorial. All right. Now, if you're looking at a number of objects and you want to arrange some of the objects in order, right? Not all of them, but just some. We have a second function that we can use, which is called the NPR function, which allows you to arrange objects in order when you have n total objects and you only want to order some of them, and we use R to denote that. So just to show you here, if you take the example right above this, we have 10 total employees. Now, if I said, how many ways can you order all 10 employees? You would just do 10 factorial and you would be done. But this doesn't say that, right? It says, how many ways can you choose 2 of them, a manager and an assistant manager? When you have a situation like this where you're not arranging everything, N always represents your total number of objects, in this case 10 employees. R represents the number of objects that you're going to order, arrange, assign. In this case, that's 2. And the NPR function is evaluated. You see you've got a little formula here by taking n factorial divided by n minus r factorial. So notice what I evaluated here. There were 10 total, so 10 factorial. I wanted to arrange 2 of them, so I divided by 10 minus 2 factorial, which was just 8 factorial. Now, anytime you're dividing by a factorial, there's a little shortcut to help you simplify. Rather than evaluating, 10 times 9 times 8 all the way down to 1, write the product, right, but only down to the factorial that's in your denominator. So 10 factorial is 10 times 9 times 8, 7, 6, 5, but stop that at 8 factorial because that's what you have in your denominator. And then you can just divide out those common factorials and you have a much easier product to evaluate. Now, I would also encourage you, if you have a scientific calculator, look to see if you have an NPR function on your calculator, because you probably do. It might be under like a stat menu or like a PRB. You might have a PRB button. But if you have an NPR function on your calculator, then rather than having to work out this formula like we did here, you can probably use the NPR function and evaluate it very quickly. Okay, so look for that and see, because most likely it's there if you have at least a scientific calculator. All right, so again, just to look at a couple of additional examples of where this is used, it's anytime you have a total number of objects, but you only want to order some of them, right? There are 40 total balls, but only 4 of them are drawn and ordered. That's how you know to use NPR. So again, I did n factorial. All right, but I don't want to evaluate that because that's a huge number, divided by n minus r factorial. And then notice again, I wrote 40 factorial, but only down to 36 because that's what's in my denominator. Then I can divide out the common factorials, and I'm only having to evaluate 40 times 39 times 38 times 37. Right? Similar situation here. I have a 6-letter password that I'm trying to put together. And if each one is a letter, right, there's 26 letters to choose from. So 26 letters, only arranging 6 of them. So again, this is a situation, and I miswrote this here. This is a situation where I could use the NPR function for 26 total letters, but arranging 6 of them in order. Okay, so again, if you want to order all of your objects, then you just evaluate n factorial. If you want to order some of your objects, then you use NPR. All right, now the third thing you're going to be looking at here in 11.7 with permutations is when you have objects that are alike. So when we talk about objects that are alike, sometimes you're looking at objects that are repeating, like if you have duplicate objects. Sometimes this means more that you have objects that are of the same type. All right, so the examples that you're looking at here and mostly what you're going to see in your homework, we've got a set of letters that we're arranging in order, but we have repeating letters. All right, that's when this is going to come into play. If you have repeating letters, any duplicating letters have to be divided out, and that's what this formula says right here. So if you look at a set of objects and you see that you have objects that repeat or that are the same, what you want to do is identify n, how many total letters do you have, but then identify any letters that are the same. All right, and we're going to call these groups K1, K2 for however many you have. So K1 for me, I looked at the I's, right? The I's repeated, there were 4 of them. K2, I looked at the S's. All right, again, there were 4 of them, so K2 is 4. The other repeating letter was a P, and so K3 was equal to 2. And what this formula states is if you have repeating letters, you do n factorial, just like always, for all 11 letters, but then you divide out any of the factorials for the letters that repeat. So I had 4 factorial for the I's, 4 factorial for the S's, and 2 factorial for the P's. And then I just evaluated. All right, similar situation here. I have 13 letters in Massachusetts, but I had to identify the repeating letters. There were 2 A's, there were 4 S's, and there were 2 T's. So I did my n factorial, but then I divided out the factorials for any of the repeating letters. 2 factorial for the A's, 4 factorial for the S's, and 2 factorial for the T's, and then just evaluated from there. All right, so 11.7, pretty much everything's going to be about ordered arrangements. All right, that's the fancy word for that is permutation. But the 3 cases are going to be if you want to order everything in factorial, if you want to order some of your objects, use NPR, and if you want to order objects where you have objects that repeat or objects that are alike, then you have to make sure you divide out for any of those subgroups.